So this video is a review of factoring. It's really a quick review. So we're going to talk about GCF grouping and trinomials like x squared plus bx plus c. Now the thing about factoring is that it's actually a pretty big topic. So I thought to make this as approachable as possible, for part one of this series, I would just do kind of the most common types of factoring if you just need like a really quick refresher of those things. And then in part two, depending on how much factoring you need to review, I've put in harder factoring. So sum and difference of cubes, trinomials of this form, or combined factoring techniques. So between the two, hopefully we can do a pretty good review of factoring. So let's talk about the most basic type of factoring to begin with, which is the GCF, or greatest common factor. So the GCF can be pretty easily explained if I have this example, 3x plus 3y. So I might say, what is the GCF of this? But the reality is it's really, I'm asking, what do you notice that 3x plus 3y has in common? And of course, you're going to say, oh, but there's a 3 in both parts of this. And that actually is the GCF. So the GCF would be 3. And so then to factor that, what I'm going to do is I write the GCF in front, and effectively what happens is I divide 3 out of these two terms, what does that leave me with? That just leaves me with x plus y. So that is what the GCF is for just one of the most basic types of factoring. So if I had something like 5x plus 10, so you would tell me then that what is the GCF in that case? And you can of course pause if you need to think about any of these. But for 5x plus 10, it would be 5. And so 5 goes into both 5x and 10. So if I factor that out, I really divide that out of the two terms, and that will leave me with x plus 2. And so you'll notice then if I were to multiply this back in, this would leave me with 5x plus 10. So it gets me back to the original polynomial, right? So if I make a slight change to that problem, I could rewrite this as 5x plus 10x. So now in this case, you'll notice that the GCF is 5, but also both of these terms have an x in them. So the GCF in this case would be 5x, okay? And so when I divide that out, so now you just have to kind of think. So if I have 5x squared and I take out 5x, what am I left with? I am just left with x. And if I have 10x, but I take out 5x, what am I left with? I am left with 2. So this is kind of one of the things that you have to watch out for then with the GCF, is just watching out for variables. So to help illustrate this maybe just a little bit better, so I have these next two examples here. So, okay, so I've got 25x cubed y squared minus 15x squared y cubed, and then 35x to the fourth y to the fourth. So in a problem like this, so first of all, I notice that all three terms have an x and a y. Okay, so x and y is going to be part of the GCF. And then the other thing I have to think about is, so I've got 25, negative 15, and 35. So what is the number part of the GCF? So the number part of the GCF will be a 5. That 5 goes into all those parts. And then I've got x and y. Okay, now what exponent goes with the x and the y? So this is a review video, so I'm just going to kind of shortcut this. I would build this up in other lessons, but I just want to kind of quickly go into this. So what you're looking for is, okay, so here's an x cubed, an x squared, and an x to the fourth. So for the GCF, it is the minimum exponent out of all the exponents. So in this case, x squared, that's my smallest exponent. So that's what I'm going to take out. And then same goes for the y. So I have y squared, y cubed, and y to the fourth. So I'm going to take out y squared. So 5x squared, y squared is my GCF. Now, I strongly recommend that you pause here and you try this one on your own just to make sure you've got it, and then hit play when you're ready. Okay, so 25 divided by 5 is going to leave me with 5. And then now I have to think, what do I do with the exponents? So I have x cubed, I'm taking out x squared. So how many x's am I left with? Just one singular x. And then I have y squared, and I'm taking out y squared. So the y squareds actually drop out. Okay, so that's how that's going to work. So now 15 divided by 5 is going to be 3. In this case, I have x squared divided by x squared, so the x's drop out. But I've got y cubed, and I'm taking out y squared, so it's going to leave me with just negative 3y. And then finally, 35 divided by 5 is 7. And then this will be x squared, y squared, because I'm taking out 2 x's and 2 y's from here. Okay, so I have one more example of this in the next one. So I strongly recommend, again, just to make sure that you've kind of got the basic idea, just pause for a second, give it a try on your own, and hit play when you're ready. Okay, and I feel like I actually should apologize here. If you hear any snoring in the background, my dog sleeps like a log. It sounds like she's cutting logs. So I apologize in advance if you hear snoring in the background, but she's too cute to wake her up. Okay, so for this one, so let's see. The largest number that divides 16 and 8 is 8. And then let's see. I'm going to take out x cubed y to the 5th. So this is going to leave me with 2y squared plus x. That is all we are going to be left with for that one. Now, if you want to practice more of these, I do have an extra practice problem set, but just to keep the video moving, I am going to talk about grouping now, but just as an FYI, there are more practice problems if you want to try those. So grouping is another common type of factoring that comes up. So grouping, this is kind of the classic grouping example. So I have ax plus ay plus bx plus by. So for this one, what you notice is that there is no GCF. There's no one singular term that goes into everything. But what you might notice is that in the first two terms, these both have an A. And in the second two terms, these both have a B. And so that is kind of your big hint with grouping, is when you notice some pattern like that. So what we're going to do is we're actually just going to factor these terms out of their respective places. So I'm going to bring the A out, so that if I take the A out of the first two terms, what am I left with? I'm left with x plus y. And if I take the B out of the second two terms, I am also left with x plus y. And now here's kind of an interesting thing to notice. Now I have, this is its own term, this is its own term. What do these two terms have in common? This term and this term both have the x plus y in common, right? So now what's kind of interesting about that is I can actually factor the x plus y out. And what am I left with? I am left with that a plus b. And so this is the idea behind grouping. And by the way, you could have written this as x plus y times a plus b, or you could have written this as a plus b times x plus y. Totally doesn't matter, tomato, tomato. But this is the idea behind grouping. So the first thing that I want to get your eyes used to is that last step. So for instance, if I have like a phrase like this, so 3 times x plus y minus 5z times x plus y, I just want to get your brain used to what do we do with that. So the thing that we're checking for is that these are the same, which they are. And when that happens, I can write that out, x plus y. And then what am I left with? 3 minus 5z. And that will be how this factors, okay? So why don't you try the other one just to make sure you've got it. So now I've got 3x minus 1 and 3x minus 1. So this is 3x minus 1. Now this one I made a little tricky. This is going to be 4x plus. So plus what? Well, there's no number in here because there is just assumed to be this invisible 1 right here. So this will be times 4x plus 1. Okay. So hopefully now we've kind of got that general idea of grouping. So now what I want to do is I want to just go all the way in with this. So I'll do the first one with you. So I've got 3x plus 3y minus 7xz minus 7yz. So again, we're looking for what do the first two terms have in common. So in the first two terms, they have a 3, and I can factor that out. And then in the second two terms, so let's see, I've got 7xz and 7yz. So it looks like they both have a minus 7z in common. So I'm going to take out the minus 7z. And in taking out the minus 7z, this becomes positive x plus positive y, right? Because I factored the negative out. And now I see that these are the same again. So I can rewrite this as x plus y times 3 minus 7z. Okay, so let's do that one more time, and then I'll have you try a couple on your own. So in the next one, so I've got 5x squared plus 10x minus 6x minus 12. Okay, so in the first two terms, what I notice is that they have a 5x in common. So this becomes x plus 2. And in the second two terms, they have a minus 6 in common. And again, this will turn into x plus 2. So remember, if you're factoring something negative out, the stuff in here will become positive, right? The sign has to flip. So then this will be x plus 2 times 5x minus 6. Okay, so next I have this example here. So I strongly recommend that you pause and you just try this one totally on your own just to make sure that you've got it, and then hit play when you're ready. Okay, so out of the first two terms, what I can factor is a 3x. And so 3x divided by 3x is 1. And then 6xy divided by 3x is going to give me minus 2y. Okay, now we got to be careful in the second branch of this. So I notice that 7z goes into negative 7z and 14yz. But what I'm actually going to do is I'm going to factor out the negative. So I am going to factor out negative 7z, which is going to flip the signs for both of these terms. So negative 7z divided by itself will become a positive 1, but be careful with the next one. 14yz divided by the negative is going to turn this into minus, right? It's got to flip the sign, minus 2y. And now we can finish the grouping. So this will be 3x minus 7z times 1 minus 2y. So that'll be the final answer in that case. Now again, I am just briefly going over each type of factoring, but if you want to practice this more, I do have extra practice problems, so I'm going to keep going, but just FYI, there's more practice for you later. So by the way, if you're finding this review helpful, consider hitting that like button or the subscribe button. And otherwise, we are going to continue on. So we're going to talk about the last type of factoring, just kind of this basic review. So we're going to talk about factoring trinomials of this specific form. So things that start with just x squared. So not 5x squared, 2x squared, just x squared. So x squared plus bx plus c. This is a certain type of trinomial form, and this is kind of an easier one to factor. Now, I'm going to talk about two different ways on how you can factor this. So the first method of how to factor this, which is my preferred way that you factor, is what's known as the trial and error method. So when we're talking about polynomials of this form, x squared plus bx plus c, really what we're looking for is we want to factor this in such a way so that it's x plus something times x plus something. But the good news is that basically what we're looking for is we're looking for two numbers here that will multiply to c and add to b. So I call this trial and error, but actually when you have a polynomial of this form, it's really not too much error with it. So for instance, in this case, if I have x squared plus 3x plus 2, so two numbers that multiply to 2 but add to 3. Well, 2 is a prime number, so this is actually like a nice straightforward one, because the only way to multiply to 2 is to make 2 times 1, and of course 2 plus 1 equals 3. So you'll notice here I've multiplied to 2, I've added to 3, so that's actually then exactly how you are going to factor this. So this will factor as x plus 2 and x plus 1. So when you have trinomials of this form, it's really what multiplies to this and adds to this, and those are the numbers that you're going to drop in here. Now, notice also that you can pretty easily check this. So if you are familiar with multiplying back up polynomials, so I've got x times x, so x times x will get me the x squared, and then I've got the 2 times the 1, so the 2 times the 1 will get me the 2. So then I just want to focus on when we're multiplying these things together. So just notice if I take x times 1 and 2 times x, so what does this give me? This gives me 2x plus, this part here is 1x, so that gets me the 3x up here. So that might not make sense the first time that I say that, but I'm just going to keep repeating it because this becomes a really quick way to check your work, but it might take your brain just a few times to kind of click over on it. Now, there is another method that you can find in books and other YouTube channels called the AC method. And I'll talk about this in both this video and the next video. So for the AC method, so it's actually a little simpler when you have a polynomial of this form. But so for the AC method, so you're kind of looking for the same thing. So you've got what two numbers, so what two numbers will multiply to 2 but add to, again, this 3. So we've already answered that question, but I'm going to show you what you do with the AC method. So we already talked about that that's a 1 and a 2. So what we're going to do then is we're actually going to use these numbers to break up the 3. So this 3 is going to become a 1x and a 2x. So I just want to show you what happens with that then. So I'm going to rewrite this as x squared plus x plus 2x plus 2. So I have just taken the 3x and just expanded this whole thing. And so this is why knowing grouping is helpful, because now what I can do is I can finish the factoring of this by grouping. So for instance, in these first two terms, I can factor out an x. So this will become x times x plus 1. And then out of these second two terms, I can factor a 2. So this becomes 2 and then x plus 1. So now you see I've got x plus 1, x plus 1. So this whole thing will factor as x plus 2 times x plus 1. Okay, so this to me is a much longer method, and you might be asking yourself, why would I ever want to use this? So I actually really don't like this method because it's a lot to remember. A lot of times people forget this part here. But in the next video, if you watch part 2 of the series, I think that this can be really handy for harder types of factoring, or also if you're just having a moment, this can just be a helpful way to help you factor this out. It's just another way to visualize it. Okay, so that being said, why don't we go ahead and just practice a little bit of factoring now. So I'll do a couple of these with you, and then I'll ask you to try some on your own. So I am going to just favor trial and error here because again, it's really not much error. So it's two numbers that multiply to 6 but add to 5. So I can really think of this as 6 is 6 times 1, or 6 is 2 times 3. And of course, if I take 6 plus 1, that gives me 7, so that's not the one that I want. If I take 2 plus 3, that will give me 5, so that is what I want. So I can rewrite this then as x plus 2 times x plus 3, and we're good to go. Now, just to show you that kind of visualization one more time too of double checking this. So notice I've got x times x is going to give me the x squared. I can do the last terms. 2 times 3 gives me the 6. So if I want to check that middle term real quick, I take this 2x times this 3x, and that gives me 5x. Okay, now what if we have some negative numbers? It's actually still the same thing. So I've got what two numbers are going to multiply to negative 12 but add to negative 1. So for negative 12, there's a few ways that we could, of course, make this, right? So negative 12, so it does get a little bit more complicated because I could have things like negative 3 times 4. Notice negative 3 plus 4 will give me positive 1, right? So I can see right away that this is not what I want. I want negative 1. But, I could go, oh, but 3 times negative 4 would work, right? So 3 plus negative 4 equals negative 1. Now, you can, of course, exhaust 2 and 6, make one positive, make one negative, but that's not going to give you this negative 1. It's only this combination here that's going to give us what we want. So this will then factor as x minus 4 and x plus 3. Okay, so now I have 3 more of these here for you. So I'm going to just suggest that if you are trying to review your factoring, that you pause here, try these 3, and then hit play when you're ready. Remember, math is not a spectator sport, so if you're trying to actually remember this, then it'll be best if you practice a few. Okay, so for this first one, I need 2 numbers that multiply to 12 but add to 7. So that's going to be just 3 and 4. So this will be x plus 3 and x plus 4. And you can notice how I can kind of quickly check this. 3 times 4 will make 12, and 3x plus 4x will give me the 7x. So we're good to go there. So now I've got x squared minus 2x minus 15. So for that one, so 2 numbers that multiply to negative 15 but add to negative 2. That's going to be x minus 5 and x plus 3. So again, if I check this, negative 5 times 3 will give me negative 15, and negative 5x plus 3x will give me negative 2x. Okay, now E I threw in there just to kind of throw you off a little bit. So what do you do with that negative sign in the front? So when you have a negative in your trinomial, what I recommend that you do is I actually recommend that you treat it like a GCF. And this is actually a great segue to the next video because we're going to combine more techniques like this. So this is kind of a preview of what's to come. So I'm actually going to factor -1 out of here because look what that does for me. This becomes x squared minus 6x plus 16. Okay, so now that I've written this like this, like all I have to do is focus on how would I factor this polynomial. Now, I do want to keep talking about this, so I'm going to give myself a little space. Okay, so now what I need to think about are two things that multiply to 16 but would add to -6. So things that would multiply to 16. 1 times 16. I have to have 2 times 8. I could also have 4 times 4. Now, I need to have positive 16 here, right? And so if I think about this, so for this to end up positive, but for these to end up, for the sum to add up negative, the two terms will both have to be negative. So the other thing that I have to recognize here is that I'm just going to throw a little minus sign now in front of all of these. These all have to be negative. That's the only way that this can multiply to something positive but be negative, right? So now if I try to add these together though, I have -1 plus -16, that equals -17. Obviously that's not going to work. -2 minus 8 is -10, so that's not going to work. And -4 minus 4 is going to be -8. Now, is there any other way that I can multiply to 16? There is not. So this one actually is kind of there just to also have the discussion of like what happens if you can't factor this. So this is the perfect example of that. I could factor the -1 out, and now that I factored it out, I actually find that, oh, the rest of this cannot be factored. So this is factored as far as possible. So this is factored as far as possible. Okay, so yeah, so that can come up too with trinomials. So it's just something to be on your toes for. Now, the last type of factoring that I want to talk about in this video is a really common type of trinomial, which is known as the difference of squares. So if I have x squared minus 9, so this is kind of a trinomial in disguise. So what this really is this is x squared plus 0x minus 9. So we can still use the same trick here. What two things multiply to -9 but add to 0? And so if you think about -9, so we can have -9 and 1, or we can have -3 and 3. And you can pretty clearly see, right? So -3 and 3, those are going to definitely add to 0. And this is why this is called the difference of squares. So this will factor as x minus 3 and x plus 3. So I'm usually not a fan of memorizing formulas, but this is just something that this is a really common one that comes up. And the format is really that you have two things that are being subtracted from one another. This is a perfect square and this is a perfect square. And I've talked about perfect squares like in terms of radicals. So a perfect square is something where something times itself is a perfect square. So 9 would be 3 times 3, or in this case, -3 times 3, but this would be the difference of squares. So this is just a really well-known pattern. Every time you see it, you don't even really have to think that hard about how to factor it. For instance, so I have x squared minus 25. So the idea here then is, so I have the x and the x, that gets me to the x squared, and then -5 plus 5. -5 plus 5 will get me -25, and -5x plus 5x will drop out that middle term, right? So what do you think we're going to write down for x squared minus 1, if you want to pause here and just write it down real quick? So this is going to be x minus 1 and x plus 1. And so that's going to be it for that one. Okay, so let's talk about then the case of what if I had like x squared plus 4. So this is called the difference of squares, not the sum of squares. So x squared plus 4, so again, if we think about this for a second, so two things that multiply to positive 4 but add to 0. So I can pretty easily come up with the list of things that multiply to positive 4, but you'll notice, right, so if I were to add these together, none of these are going to equal 0. So x squared plus 4, this is a really common trick to kind of play on people to see if they really understand factoring. This cannot be done. So this is already factored. Sometimes, by the way, instead of saying it's already factored, sometimes you might also hear the word prime. Factored or prime, it just depends on what system you're talking about. And the last thing that I want to talk about here is so x squared minus 4 over 9. Okay, so this is still the difference of squares. So the fun thing with the difference of squares is that you can start to just keep following the pattern. So 4 is a perfect square and 9 is a perfect square. So for something like this, so how would this factor? Well, just think about, okay, so why is 4 a perfect square? It's because it's 2 times 2. And why is 9 a perfect square? It's because it's 3 times 3. So this is kind of the fun thing that you can do with the difference of squares. So I've got minus 2/3 and plus 2/3. So I've got that set up, and then it really just continues the pattern. So you don't even have to like panic too much about it being a fraction, and that's kind of like one of the quote unquote fun things with this. Okay, so by the way, you can't master math by just watching a ton of YouTube videos. You do have to practice this. So each video that I have has a companion additional practice problem set. So this is a PDF of problems and answer key plus a video showing you how to work any of the problems. So if you are trying to really master this, go test yourself with that and see how well you know the topic. Just go to divideandconquermath.com and go to the review section. By the way, my review series has many other topics in it. It's not just factoring. So every topic works like this. It has a refresher video, practice problems, answer key, all the worked out solutions, all that good stuff. So it's all at divideandconquermath.com. Just go to the review section. Everything is there for free. And with that, I am going to leave it here. I hope to catch you guys in the practice video. I'll talk to you next time.